Okay, so last night I asked you guys to look at a free response question with respect to sampling distributions and a mean, and let's take a look at this one. So you have a principal from a large high school, right? To investigate, he printed out a list of the number of absences during the last month for each of his 2,500 students at the school. So for this population of students, the distribution of absences, so we actually have the population mean. The population mean here is 1.1 absence per student, and the standard deviation here is 1.4 absence per student. Okay, so there we go. All right, so let's take a look at what the questions are here. We took a sample. So we took a sample. Took a sample of 50 students. So my sample size is 50 from the printed list. So what is the shape of the sampling distribution of the sample mean? All right, so shape here is going to be bell-shaped and symmetric, or you could say normal, right? This is a normal distribution. How do I know it's a normal distribution? So although the population is skewed right, according to the facts of the problem, skewed right, I have a sample size of 50, which is bigger than 30, which is enough to get me to the central limit theorem, which guarantees normalcy. So this is going to be a normal distribution. Okay, so that's part A. Part B. All right, what are the mean and standard deviations of the sampling distribution? Well, since the mean is an unbiased indicator, the mean of the means in the distribution here will be the same as the mean of the population. And because I met the 10% criteria, right? Because the sample size of 50 is less than 10% of the population, which is 2,500. I know that the standard deviation of the means is going to be equal to the standard deviation of the population divided by the square root of the sample size. So I go grab my calculator, right? I want to clear everything out here because that's just fair to you guys to see this from the ground up. So this is 1.4 divided by the square root of the standard or of the sample size, right? Which is going to give me approximately 0.198. Fantastic, right? So met the 10% criteria, got through that, so I have the mean and the standard deviation for the sample distribution. All right, so part C asks me the probability question, right? So what is the probability that the mean number of absences in a random sample of 50 students is less than 1? Okay, so, all right, here's my distribution. The mean of my samples, right? The mean of my samples is here at 1.1. The standard deviation of my samples I just found as 0.198. So the question is what's the probability that I'm 1 or below? Probability that I'm in this tail. So this is where I go to the calculator and I go second bars. And I need the normal CDF, which is option number 2. My lower bound is not there, so I need like an extreme value there. My upper bound is 1. The mean of my population is 1.1. The standard deviation of my population, or my sampling distribution, is 0.198. I paste that, and that gives me that the probability that a sample mean would be less than or equal to 1 is approximately 0.0307. So around 31% chance of grabbing a sample where the mean of the sample is less than 1 absence per student for that month. That's like pretty good, I think. All right. So, not too bad. Let's take a look at part D. D is like the meaty, more theoretical question in the whole thing. So let's drive down there. Part D asks the question, because the population distribution is skewed, the principal is thinking, oh, let's grab the median, right? Because there might be like an outlier here that's dragging things across, like some student who is absent all the time, and that if he hits the sample, that he's going to move the sample to the right, okay? So he says, what if I'm going to grab the median? So how would I find a standard deviation for the sample distribution of the medians? All right, so let's think about this. I'd have to take samples. So take SRS of n equals 50 samples from the list. And I would need to have many of them. How many? Lots. This is one of those places where you can be a little bit ambiguous on the AP exam, because it's like, how many? Lots. Many would mean like you're probably hundreds, thousands of them. I mean, like the ideal world here is you would just find all the possible samples that you could take from 2,500 students of size 50, but that's like a lot, like just to see how many that would be. The possible samples would be 50, right? No, sorry, that's not right. 2,500, right? And that would be permutations, because combinations, because order doesn't matter, right? Combinations. Choose 50, right? So out of 2,500, choose 50. Oops, I got that. Well, and like the calculator just can't even calculate that. That's awesome. So that number is way too high. It just gives me an overflow error. Lovely. So you're not going to do all the samples. That's why we're doing a simulation here, right? So what we're going to do here is we're going to say, okay, we're going to take many samples, enough that I can get a feel for things. And then what we're going to do is we're going to find the median. And I'm going to call that x tilde of each sample. Okay, so x tilde is not like x bar. X bar is like standard notation. I tend to use x tilde. There are other statisticians who use x tilde, but we're just going to let that be for the moment. So if you do that, just make sure you note that that's the median for each sample. So, and then you now have a list. You have a list. So the mean of the medians is going to be the mean of the list that you generated. The standard deviation for the medians is going to be the standard deviation of the list that you generated. Okay, so now you have a sampling distribution, kind of, for the median. Well, at least you know what the mean of the sampling distribution for the median is, and you know what its standard deviation is. So that's all the question asks. It's like, how would you find the standard deviation? And you could do that. You could just go and take a bunch of samples of size 50, right? Find the median of each of those samples, and then take the list and find the standard deviation for that list. Fine. Now, the question is like, is this useful? So this is like the real world question. And the answer is no. Why is this not useful? Because the median is not an unbiased indicator. Haha. The only time it actually is an unbiased indicator is when the set is symmetric. But in that case, the median is equal to the mean. So so what? But here my set is not symmetric. In fact, that I'm told that it is skewed to the right. So we are not an unbiased indicator. Because we're not an unbiased indicator, I don't get normalcy. And that makes this not as useful as I would like it to be. Now, this indicator is valid because what has to be valid for this to be valid? Well, this has to meet the 10% criteria. And the sample size of 50 is still less than or equal to 0.1 times 2,500, right? So 50 is less than 250. So that's good. But no, this is not particularly useful. So problem ends here, right? But this is just like, there's where the end of the problem is. You finished it. But this is some additional analysis that may tell you why we don't do this, right? Why we like using sample means, because it allows us to do some sort of inferencing. All right, so there you go. That's it for the free response problem there.